Hello guys, I welcome you all to this video. Today we are going to study about projectile motion. First, let us go through a brief overview. At first, we will talk about introduction, then we will derive various important expressions for projectile thrown from the height. Similarly, we will also be talking and deriving the expression for the projectile thrown from the ground, and we will conclude this video with some examples. Now without further delay, let's get into an introduction. Let's say when you throw a certain object at an angle, it follows a certain path, doesn't it? And that very object falls on the ground. Here, the object is called projectile and the motion shown by the object is known as projectile motion. The motion of the object is in horizontal and the vertical direction. So projectile motion is two-dimensional motion. There is no force in horizontal direction, so according to Newton's second law, velocity should be constant. Hence, horizontal velocity remains same in projectile motion. Since the gravity which acts vertically downward, the vertical motion changes with time. Some of the examples of projectile motion are the football kicked by the players, bombs deployed from cannon, missiles, etc. Let us now talk about the basic terminologies which will be used throughout the session. Now, defining the projectile in a very proper way, I would define it as any object thrown such that they are allowed to move only under the influence of gravity. If you throw the ball upward, then the projectile is ball, and if you throw the stone is projectile. The projectile shows certain motion, and this motion is known as projectile motion, as I mentioned earlier. The maximum vertical height reached by the projectile during its duration in the air is called maximum height. The horizontal distance covered from the point of projection to the point of landing of projectile is called horizontal range. And the time projectile remains in the air is called the time of flight. Let's move into the projectile thrown from the height. Consider a projectile thrown from the certain height edge with initial velocity u horizontally. The horizontal velocity is u and the vertical is 0. Now, using the equation of motion in horizontal. In horizontal, there is no force, hence no acceleration, but the initial velocity remains u. The expression for the time small t becomes as shown. Let it be equation 1. Then, using equation of motion in vertical direction, the vertical acceleration due to gravity is z, but the vertical velocity is 0. So we get y equals to half gt square. Let it be equation 2. Now, from equation 1 and equation 2, we get y is equal to half g into square by u square. It is in the form of y equals to ax square. It is the equation of parabola. So, the path of projectile from height edge, which is also called trajectory, is parabolic in nature. For the time of flight, let's use equation of motion in vertical direction. Now, the vertical velocity is 0 and displacement is h when time is time of flight. So we get the time of flight equals to square root of 2h by g. For horizontal range, let us use equation of motion in horizontal direction. Horizontal acceleration is 0 when the time of flight is capital T, then horizontal distance is capital R. So we get capital R equals to u times capital T and finally u times square root of 2h by g. For the velocity at any instant t, let us use an equation of motion of the following form. In x direction, the velocity remains same, so Vx is equal to Ux, which is u. In y direction, Vy equals to Uy plus Et, but Uy is 0. So we get Vy equals to 80. Now, the total resultant velocity is equal to the square root of Vx square plus Vy square. So, we finally get V at time t equals to square root of u square plus at whole square. Now, let's derive important expression when projectile is thrown from the ground. Let us consider a projectile is projected from the ground with initial velocity u making angle theta with horizontal as shown in figure. Capital H is the maximum height and capital R is the range of motion. Horizontal velocity is ux equals to u cos theta and vertical velocity is uy equals to u sin theta. Now, as in projectile from height, let us use the equation of motion. In horizontal direction, horizontal velocity is u cos theta. Horizontal acceleration is 0, so x is equal to u cos theta times t. Hence, t equals x by u cos theta. In vertical direction, horizontal velocity is u sin theta. Horizontal acceleration is minus g. So y is equal to u cos theta times t minus half gt square. When putting the value from the previous result, y equals to tan theta x minus g by 2u square cos square theta times x square. It is in the form of y is equal to ax minus bx square, which is the equation of parabola. So the trajectory of projectile thrown from the ground is parabolic in nature. Now let us derive expressions for the time of flight, horizontal range and velocity at any instant starting with the time of flight. Using equation of motion in vertical direction, net vertical displacement is 0 when projectile hits the ground. So putting y equals to 0 and replacing small t with capital T, now with the little simplification we get value of time of flight as 2u sin theta by g. For horizontal range, let us use equation of motion in horizontal direction. Horizontal velocity is u cos theta and horizontal acceleration is 0. So x is equal to u cos theta t. Now, when x equals to capital R, the time t is equal to time of flight. Replacing the value of time of flight, we get horizontal range as capital R equals to u square sine 2 theta by z. For the maximum height, let us use equation of motion in vertical direction. At maximum vertical height, the vertical velocity is 0. Initial vertical velocity is u sin theta and acceleration is minus t. Solving for displacement at which the vertical velocity becomes 0, we get height as u square sine square theta by 2z, which is the expression of the maximum height. With this, I would like to conclude today's session. And for more such videos, please don't forget to like, subscribe, and comment on our channel. Thank you.